Determine the equation of the circle that has center 5, -2, and passes through the origin. I always like to just have a look at what they're saying. All right, I love when we have a look at what they're saying. So I like to sketch a circle just to have an idea what they're saying. Here's a circle, right? They said the circle passed through 5 minus, the center is 5 - 2, so let's say that's the center, 5 - 2, and the circle passed through the origin 0, 0. So if this is 5, 0 will be somewhere over here, so the center is somewhere here. All right, this is 0, 0, the origin. So what that means is this is the origin. That point is 0, 0. All right, and then it asks us find the equation of this circle. Now the equation of the circle is going to be, we need to find the length of this line, and then that will give us the radius. All right, since it's the origin, the length of the line is just going to be x 5 minus 0 square, which is 5 square plus 2 square. All right, so what we're saying is the radius is just going to work out to be the square root of 5 square plus 2 square. That's what the radius is going to be, which is the square root of 29. So the equation of the circle is x minus 5 all square plus y minus 2, which is y plus 2 square. Y plus 2 all square is equal to r square. What is r? R is just r square, so that's just 29. That's going to be the equation of this circle. Nice and easy, soft. Now, the next part of the question now, it says determine whether the following pair of lines is parallel. Determine whether the following pairs of line is parallel. Now, the only way the lines are parallel is if the gradients are the same. Are the gradients the same? Let us find out. So, make y the subject from the first one. Let's make y the subject. Making y the subject, we'll say that y is equal to 4 minus x. All right, and so from the first one, the gradient is -1. So we can conclude that the gradient is -1. That's from the first line. Now, what are we getting from the second one? Making y the subject, we bring over this, and we're getting that 2y is equal to 3x plus 3. And so no, clearly the lines are not parallel. From this line, we're getting that the gradient is 3/2. All right, the gradient is 3/2. So what can we tell them? We can say absolutely not. We can say no. The lines are not parallel. These lines are not parallel. Nice and easy. Part C now, which is vectors, it says the position vectors of 2 points A and B relative to the fixed origin O are given by OA is 2i plus j and OB is 3i minus 5j, where I and j represent the unit vectors in the x and y directions, respectively. It says calculate the magnitude of vector AB. So to calculate the magnitude of vector AB is going to be equal to vector OB minus vector OA. That's vector AB. Vector AB is OB minus OA. Alright? That's how we find vector AB. Now that vector AB is vector OB minus OA, so vector AB is going to be 3 minus 2, 3 minus 2, and so 3 minus 2 is 1, so we get I, and then minus 5 minus 1 is minus 6j, so that's vector AB. But they want the magnitude of vector AB. And so the magnitude of vector AB is going to be equal to the square root of 1 square plus 6 square. That's the magnitude of vector AB. So the magnitude works out to be the square root of 36 plus 1, which is 37. So the magnitude of vector AB works out to be 37 units square. All right. Now, part 2. Part 2 is it asking for the angle AOB. The angle AOB is the angle AOB giving your answer to the nearest whole number. It's asking you for the angle AOB giving your answer to the nearest whole number. Now, using your angle, the angle AOB giving your answer to the nearest whole number. Now, let's do that now. All right. So I like to just do a sketch on the graph. I just love to put it on a sketch just to see what we're actually finding. Angle OA is 2, 1. So 2, 1, this would be the point A. X is 2, Y is 1, this is A. B is the point 3, negative 5. So B is somewhere right here. So we want angle AOB. So this is the angle that we want, AOB. So angle AOB, first thing we need is we need vector OA and the dot product vector OB, and we need their magnitudes. All right, so first thing, let's work out what is OA dot OB. OA dot OB, work out the dot product first. OA dot OB is equal to 2, 1 dot 3, negative 5. So we work out this now, and it works out to be 2 times 3, which is 6, minus 5, and 6 minus 5 is 1. So that's OA dot OB. 6 minus 5, which is 1. Now that we get that is OA dot OB, what's the next thing that we need? The next thing that we need now that we find OA dot OB is we need the norm of OA. The norm of OA is equal to, the norm of OA is 2 square plus 1 square, square rooted. That's the norm of OA. And so what we're getting then is 2 square plus 1 square is 5. And so the norm of OA is the square root of 5. Next thing we need is the norm of OB. The norm of OB is going to be equal to the square root of 3 square plus 5 square. The norm of OB is 3 square plus 5 square. And that works out to be equal to 3 square plus 5 square That's the square root of 34. And so now we're ready to find angle AOB. All right, now we can find it. Now angle AOB, we can find it. Angle AOB is going to be equal to cosine inverse. Angle AOB is cosine inverse of OA dot OB. So it's equal to 1 divided by the norm of A times the norm of B. The norm of A times the norm of B is the square root of 5 times 34. So we know we can join two surds as 1. All right. So when we work this out now, what is the square root of cos inverse of 1 over the square root of 5 times 34? 5 times 34 is 170. The square root of 170 is 13. 1 divided by 13 is 0.07. Cos inverse of 0.07 is 85.6 degrees. Giving your answer to the nearest whole number is 86 degrees. Who can also almost get a 90-degree angle? So yeah, 86 degrees. That's angle AOB. So our sketch is relatively accurate. Nice and easy, and that take care of question 3. Soft. Question 4. Question 4 says a wire in the form of a circle with radius 4 centimeter is reshaped to form a circle with radius 10 centimeter. Determine in radians the angle of the sector given your answer in terms of pi. So it tells us that we'll have a wire first in the form of a circle with radius 4 centimeter is reshaped in the form of a sector with radius 10. So I always like to just draw a little diagram, just so I always see what I'm talking about. So I tell you that we have a circle with radius being 4 centimeter, and then this is reshaped to form a sector. Sector looks something like this now. This is a sector, and they tell us that the radius of the sector is 10 centimeter. And it says determine the angle of the sector. Let's call this theta. Now, first thing we know about this is that the area of this small circle, the area is pi r squared. The area is pi r squared, and pi r squared is pi times 4 squared, which is 16 pi. So that's the area of the small circle. So the area of the small circle is the area of the sector. So what that means is 16 pi is equal to a half r squared, which is a half 10 square theta. A half 10 square theta. So we're going to transpose for theta. All right, a half 10 square. So we're getting 0.5 times 10 square is 50. We divide both sides by 50. So what that implies then is that theta is equal to 16 pi over 50. That is theta, 16 pi over 50. Which is 8 over 25 pi. Nice and easy. Now it says, solve the equation sine square theta plus 3 cos 2 theta is equal to 2. And it says, give your answer correct to 1 decimal place. So it says, solve the equation sine square theta plus 3 cos 2 theta equal to 2. And give your answer correct to 1 decimal place. So let's go ahead and do this. To solve this equation, we can rewrite cos 2 theta as 1 minus 2 sine square theta. And you might say, so, sir, why would you want to rewrite cos 2 theta in terms of sine? Now, since I have sine square here, I just want everything to be in terms of sine square. So I'm going to rewrite this as plus 3 times cos 2 theta is 1 minus 2 sine square theta. I want everything to be in terms of sine. And all of this is equal to 2. Alright? Now, since this is equal to 2, I can expand to get sine square plus. Now, sine square plus minus 2 sine square. 3 times 1 is just 3. And then I'm getting 3 minus sine square theta is 2. Then I can bring over sine square theta. Bring over sine square theta. Bring over 2. And so what I'll get is bringing over sine square, bring over 2, I get sine square theta has to be 1. Think about it this way, 3 minus 1 equal 2, so sine square theta is 1. If sine square theta is 1, then that means the sine of theta is equal to plus or minus 1. So sine theta is equal to plus or minus 1. Alright, sine theta is equal to plus or minus 1. If the sine of theta is equal to plus or minus 1, then theta is going to equal to sine inverse of 1, which is pi by 2, and sine inverse of minus 1, which is pi by 2. Alright, then it's going to be pi minus pi by 2 and pi plus pi by 2. But pi plus pi by 2, so now I'll just leave it right here, that theta is just pi by 2. Alright, because if we draw the circle to show where it says, this is what it says, theta is between 0 and pi, so the answer that they want is just the first two quadrants. The answer in the first two quadrants is pi by 2. So if they want to give it as a decimal to one decimal place, that's 1.6. That's 1.6, pi by 2. You can check it too. Alright, you can always check it to make sure you're right. So checking it, sine square theta, which is 1 plus 3 times the cos of 180. Nice and easy. So that's what we get. Theta is pi by 2. Now the next part of this says, prove this identity. So let's prove this identity. So prove identity always start with the left-hand side. And you try to prove that the left-hand side equal the right-hand side. So the left-hand side that they give you is 1 over 1 minus sine x. We have 1 over 1 minus sine x minus 1 over 1 plus sine x. Alright, 1 over 1 minus sine x minus 1 over 1 plus sine x. Alright, now in order to do this what we're going to get is, we're going to form one big LCM, and the LCM of 1 minus sine x and 1 plus sine x is just 1 minus sine square x. So that's the LCM, 1 minus sine square x. Now 1 minus sine x into this leaves 1 plus sine x. minus, now 1 plus sine x into 1 minus sine square x, leave 1 minus sine x. This is 1 minus sine x. So now when we work this out now, this is going to be simplified to be, this is now equivalent to 1 minus 1 that gone, sine x minus minus sine x, sine minus and minus here plus, so this becomes 2 sine x, this becomes 2 sine x over, this becomes 2 sine x over 1 minus sine square is cos. 1 minus sine square is cos square. Now this part becomes very easy. Alright, so what we have is 2 sine x over cos square. We can rewrite this as 2 sine x over cos square in the denominator can be broken up as cos x times cos x. We can break it up as cos x times cos x. That's cos square. Now, when you have now 2 sine x over cos x is just sine over cos is tan. So this works out to be 2 tan x over cos x. Nice and easy. So this is your right hand side. Nice and easy for this proof, soft.